At 6 o'clock, a spider starts to walk at a constant speed from the hour hand anticlockwise round the rim of the clock face. So we have, if I may draw some clock face, a rough drawing. So this is my clock face, and so that would be the hour and minute hands. That's a minute hand, 12 and 6. So the spider is here and it starts to walk. When it reaches the minute hand, so it starts to walk anti-clockwise, okay? The minute hand would be moving clockwise, of course. So the minute hand, by the time the spider is walking, the minute hand would have reached somewhere there. Now we assume that the spider has traveled for y minutes before it reaches the minute hand. Okay, and the minute hand in that y minute will have moved x degrees. So that's the first part. May I write that down? So we have spider and we have the clock, the minute hand. So the spider in y minutes has moved. So you see, we have to write the angle. So if this is x, the other angle would be 180 minus x. Okay, so in y minutes the spider would have moved 180 minus x degrees, and the clock, the minute hand, in y minutes, the minute hand of the clock would have moved x degrees. So obviously the spider is faster. You know, the spider is faster. So than the minute hand, the movement of the spider, the speed. So we say, if you can write, so spider moves faster than the minute hand. This is an important bit to understand, and it is confirmed by the second sentence, or the second statement, that when it reaches a minute hand, the spider turns around and walks round the rim in the opposite direction at the same constant speed, reaching the minute hand again after a further 20 minutes. So that spider would have reached the minute hand again after a further 20 minutes. So let's say that's somewhere here. So this distance would be 20 minutes. And this is the distance that's traveled by the minute hand, not the spider. If you want to see this, the spider would have traveled all the way, taken the loop, and then reached the, or sort of reached the minute hand or touched the minute hand. So the spider would have traveled 360 plus whatever the angle the minute hand has moved in 20 minutes. So if I can write, so for the minute hand, we know some things. We know that 360 degrees, the minute hand moves in 60 minutes. Or the other way around, it goes 60 minutes. It would have done 360 degrees, so 1 minute it would do 360 divided by 60, and that equals 6 minutes, or 6 degrees, sorry, 6 degrees. So therefore in 20 minutes the minute hand would have gone 6 times 20, and that is 120 degrees. So this degrees would be 120 degrees. If I were to name it O, A and B, so angle AOB would be 120 degrees. Okay, and AO, and if I name it C, angle AOC be easier to name the angles, angle AOC equals x degrees. And when I said 180 minus x, so I should name that to, if I call the 6 base, if I increase, make this, then the angle AO, I may call it B. Oh, no, B is already there. So AOM, if I call it M, angle AOM would be 180 minus x. So these are the this will help us get to the solution, understand like how to get to the solution. So 20 minutes, it will have moved 120 degrees. And now how much has the spider moved in 20 minutes? The spider in 20 minutes will have gone 360 plus 120, that is 480 degrees, because it meets the clock again, the minute hand again at this point. Okay, so it will have gone another 120, 360 plus 120, that's 480. So if you now compare the two, the 480 and the 120, so the spider is faster by how much more, or how many more degrees will it have covered. So if I say spider is quicker by, so I can write 480 divided by 120, that is 4 times. The spider is 4 times quicker. So therefore, the speed of the spider is 4 times more than the speed of the minute hand. So speed of spider is 4 times the speed of the minute hand. So what I can now write is, what is the speed of the clock? The speed of the clock, you see, is y minutes. It goes x degree. So in 1 minute, it would go x out of y degree. And for the spider, in y minutes, it does 180 minus x degree. So in 1 minute, it would go 180 minus x out of y degrees. So what is happening here, I mean what we aim to find, you might have guessed, we need to find the time. So to find the time, we have to find the degree. If we can find x, and if we can work out the degree movement of the minute hand, we can work out the time. So that's what we are trying to do. So then we can equate this, we can have an equation here. So we can say, because the spider would be 4 times faster, 180 minus x out of y would be 4x out of y. And if we cancel the y's, we would get 180 equals, therefore 180 minus x equals 4x, and therefore 180 equals 5x, and therefore x equals 5 times 3 is 15, 36. So x is 36 degrees. So once we know x is 36 degrees, so we can work out 36 plus 120, that is angle COB. Therefore, angle COB is 120 plus 36 degrees, and that is 156 degrees. So 156 degrees would mean how many minutes? So we can work that out from here. 1 minute is 6 degrees, or 6 degrees is 1 minute. So 156 degrees. So 156 degrees would mean 156 divided by 6, that is 6 times 2 is 12, that is 26 minutes. So we are taking this from here. 1 minute is 6 degrees, 6 degrees is 1 minute, so 56 degrees would be 26 minutes. So this angle COB, 156 degree, is 26 minutes. So we already know the hour hand is at 6, it's 6. So it will have moved somewhere here, the hour hand, but it would still be 6 o'clock. So 6:26. So the time would be 6:26. So the answer would be 6:26.